In this video, we will discuss about allotropes of iron. So first of all, what is allotropy? Allotropy is a characteristics of a material that there exist different phases at different temperature. For the same material like iron, if we change the temperature, there will be different phase at different temperatures. So that is called as allotropy, and we have three allotropes of iron. We'll see that at 1539 temperature and above that we have liquid phase of iron. So here is the graph for allotropes of iron. If we cool iron with respect to time, means continuously if we cool, then at different temperature we get different allotropes of iron. The first one is it will change its phase from liquid to solid up to this point. After that, if we reduce the temperature, because this latent heat if we take out, then iron will be in solid form. Now further reduction in temperature will give us the sensible heat. So if we take out the sensible heat, then it will transform into delta iron phase, which will be having a crystal structure of BCC. So till 1400 degrees Celsius we have BCC structure with delta ferrite. When we look iron into microscope, we get a certain pattern of iron which we call as a delta ferrite. So it is one particular allotrope. Its crystal arrangement will be body centered cubic cell. Now when we further reduce the temperature, it will give this horizontal line at a constant temperature of 1400 degrees Celsius. So at this temperature there will be transformation of crystal structure from delta iron to gamma iron. Gamma we all know as in austenite. So this horizontal line at constant temperature, the entire iron will change from BCC structure to FCC structure, and these both structures are non-magnetic in nature. So there will be transformation of crystal, and after that if we reduce the temperature from 1400 degrees Celsius to 910 degrees Celsius, there will be gamma iron. After that, if we further reduce the temperature, there will be a constant temperature line before that. So that 910 degrees Celsius temperature will again, there will be crystal structure transformation from gamma iron to alpha iron. Now once it is fully transformed, it will be again into BCC structure, and it will be non-magnetic in nature. So these all three structure which we have discussed, delta, gamma and iron, till 768 degrees Celsius, these all are non-magnetic, but there will be magnetization after 768 degrees Celsius. If we further cool it, there will be transformation of magnetism, means the material will get magnetized. So what happens, it will remain into alpha iron phase, which is BCC structure, but the material will become magnetic in nature. So if we reverse this process of heating, then it will follow the reverse path with respect to time. But again, after 768 degrees Celsius and above that, the magnetism will be gone. We call this point 768 degrees Celsius as a Curie point, which is very important information for various competitive exams. In fact, this question was asked in BRC, and after that it will be BCC structure with magnetism. So we have three allotropes of iron. So here we have to see that there is a transformation of magnetism in the same crystal structure, and here we have transformation of magnetism here, and here the transformation of crystal structure. So this is not a latent heat, there will be constant temperature by changing in the allotrope of the iron, not because it is changing the phase from liquid to solid. So now we'll discuss some points regarding delta iron, alpha iron, they both have BCC structure, delta and alpha. So BCC structure, we know that its atomic packing factor is 0.68. That's why the dislocation motion has to gain more energy to glide through to glide till the grain boundaries. So that's why it is strong and hard. But gamma iron is FCC, which has 12 slip systems. So if we apply external load, it will be easy to deform it. So it is ductile in nature, and alpha and delta iron are strong and hard in nature. Sometimes it is brittle also, but the gamma austenite is ductile in nature. So these are the allotropes of iron. See you in the next video.